Hello, everyone. Welcome to Alltop School Classroom. Today, we're going to go over 2021 National Mathcounts Spring Round, question number 27. Actually, this question, at the competition day, nobody got it. So that's treated as the most difficult problem. All right, let's check this question. Suppose that m and n are real numbers such that the graph of y equal to m times parentheses x minus 12, y equal to 10 minus x over m, y equal to n times x minus 6, and y equals negative 4 minus x over n, all intersect at a single point AB. What is the value of a plus b? Basically, we try to find out the intersection points for all of these four lines. So we observe the four lines. There's obviously some pattern here. The first two lines, the slopes are m and negative 1 over m. So they are perpendicular. The second group of two lines with slopes n and a negative 1 over n. The two lines are perpendicular. So for this question, we're going to give you two solutions. One is using the algebraic way to solve it. The other method is going to do the geometric method. So today we're going to give both of the methods to solve this problem. So let's do the first method. We're going to do the algebraic way to solve it. So A, B satisfy all the four equations. So that's why we can plug in A and B into the equation. For the first one, will become B equals m multiplied by A minus 12. So from here, we can solve for the slope m directly because we try to eliminate them. So we solve for this m. And then for the second line, plugging A and B into it, you get a B equals 10 minus A over m. So we can solve for the m as well. So for these two m, definitely will be the same. So we make them equal. So A over 10 minus B equals B over A minus 12. So we set up this equation. So after you simplify, we're going to get this the equation about A and B for the two variables. So we only have two variables. We need another two variable equation, and we should be able to solve them. So the same way we can put the second group of lines together and then solve for the first one because A and B are on the lines. So we're going to plug in B equals n times A minus 6. And we can solve for the slope, n equal to B over A minus 6. And then the same thing for the second line, AB is on the line. We can solve for the n as well. So these are talking about the same value of the slopes. So we're going to make them equal, set up the equation. So we're going to get the second equation about A and B. That's nice. So we get the previous page, we're going to get the one equation about A and B, quadratic. And now we get the second one, the quadratic equation for A and B. So once we get these two equations, we put them together. And then we should be able to solve for the A and B easily. Okay, because these are A squared plus B squared, we can eliminate them to make them to be linear equation to write one in terms of the other one for the linear relation. So we can just subtract the two equations, we get a 6a plus 14b equals 0. So simplify by dividing by 2. So we get the simplified equation 3a plus 7b equals 0. And then from here, we get the relation b in terms of a, b equal to negative 3a over 7. That's the third equation, we get it. So once we get this linear equation, we can just substitute into any of these above equation. We can just solve for the quadratic equation. So for example, I'm going to substitute into the second one because this is a coefficient a little bit smaller. Going to substitute into it. We're going to get a squared plus 9 over 49 a squared minus 6a minus 12a over 7 equal to 0. You see we have a everywhere. We're going to cancel the a because a cannot be equal to 0. We're going to explain that a little bit more. A definitely cannot be equal to 0. If a equal to 0, you can think about it. The b equal to 0, that will be on the origin, but the line in the previous one, we can see if x equal to 0, and then that means y equal to -4. But that's not right. So because from here, we can get a equal to 0, b will be equal to 0 at the same time. So that's why we can just cancel this a directly. And then we can solve this linear equation. We get the value of a, 189 over 29. So once we get this a, we can just plug in into the third equation. We can solve for the b. And then we just directly say a plus b equal to a minus -37a, and then you get a 47a. And then by plugging the value of a, you can find out the sum, which is 47 times 189 over 29. You get the result 108 over 29. So we get the answer then. We have geometric method to solve this one. I'm going to share with you for the second solution as well. So that will be using geometry, coordinate geometry properties. You can see the first two equations, they are perpendicular because the two lines have slopes m and -1 over m. So the first line obviously passing through the point 12, 0. We call this point A. And then the second equation, this passing through 0, 10. We call this line B then. Okay. And then in that case, because they are perpendicular, so we can tell the intersection of the two lines is on the circle. And also the center will be exactly the midpoint of these 2 points. And also the diameter will be the distance between them. That will be square root of 61. So we're going to show you the diagram in a moment. You can see why they are on the circle. So you can obviously see the 2 points A and B from the equation. And also the two lines perpendicular to each other. That's why it's the intersection point located on a circle, because that's on the right triangle. The connection between A and B will be the diameter of the circle. Okay, and then from here we get the center of the circle and also diameter length. So you can see from here, the circle, the one line with a slope of -1 over m. This is a slope with m. They are perpendicular to each other. They are certainly located on a circle, and because this is a right angle, so the intersection point will be on this circle. From the coordinates A and B, we can find out that will be the midpoint of A and B. So that will be, this is 12, that becomes 6 for x coordinate. This is 10, so the y coordinate for this midpoint will be 5. So from here we get the equation of the circle, x minus 6 plus square plus y minus 5 square equals 61, because we just got the diameter length square root of 61. So you get this equation. We can do the same thing for the second group of a line. They also located in a smaller circle. So you can check next. So these two lines with the slopes n and a -1 over n. So the slopes are with the product -1, so they are perpendicular to each other. And then the first line pass through 6, 0. The second line pass through 0, -4. similar to the previous group. So we can find out this intersection point of the line is also on a smaller circle. That's with the diameter CD. And the center will be the midpoint of this CD. So the diameter will be the distance between C and D. You see, 6 squared plus 4 squared, take the square root. I get actually, this is a radius. This is half of the diameter. So I shouldn't write as CD should be directly get the 2 square root 13. We're looking for the radius. Okay, so the radius should be square root of 13. Same thing for the previous example. The radius should be square root of 61, not the diameter. Diameter should be 2 square root of 61. So we get this equation. The same thing for this, we're going to get the diameter 2 square root of 13. And then we can get the equation. You can see passing through C is 6, 0. D is 0, -4. So the two lines perpendicular to each other. So the center will be on the hypotenuse, CD. And then you get the midpoint, -4 divided by 2, -2, 6 divided by 2, 3. So the center is on 3, -2. And then you can find the distance from here. The diameter will be, the radius will be square root 13. So you can find this equation. So very similarly to the previous one. All right, so once we got this one, we know the four line will be intersecting, the first two line intersecting on this circle, the second two line intersecting on this circle. But the four line intersecting at the single points, so that means they must be on the intersection point of the two circles as a common points of the two circles. So that end up with what? The four must be concurrent at the intersection point of the two circles. So you can see must be on this intersection point. However, you can see there's 2 points. One is on the origin, one is over here. I label as red dots. We can prove this cannot be on the origin. So the only single point they intersected will be this one. So one of the intersection point is origin, but 0, 0 origin is not on the line here. You can see 0, 0, it turns out x equal to 0, y should be equal to 0, should be equal to 10, now equal to 0. So that's why the origin is not on this line specifically. I don't even need to check the other lines, but even this line already failed. So the intersection point of four line must be on this second intersection point. That's labeled as the red dot. So that means we only need to figure out the intersection point of the two circles. We can get it. But solving this two circle intersection, we can do it, but that may not be the smarter way to do it. Because these two intersection points have the common chord. The common chord will be intersecting with the connection of the two centers. So we can utilize the intersection point of this O1, O2, and the common chord. That point we call M supposed to be the midpoint of this origin and these red dots. So in that case, we can find out red dots after we get this intersection point. So that's the smarter way to do it. You can see, get the two circles, we subtract each other. And these will be what? This will be the line through the intersection point of the two circles. Okay, the two circles you can see O1, O2. That will be, this is the O, this is we call P. That should be intersection points connecting this intersection point. So we just subtract the two equations, we get an intersection line equation. Okay, that's the nice way to find out the intersection line. instead of really finding something in the section point, get the slope, get some other information to get the line, we can directly manipulate the two equations, we get the intersecting line easily. So let's take a look at the diagram. You can see this is an intersection points between the two intersection point of the two circles. And also we have O1, O2 as the connection of the two centers. So these connection will be perpendicular to OP. So once we find the M, we basically done because that will be the midpoint of OP. Okay, so OP is the common chord of the two circles. It is perpendicular to the line connecting to the two centers, O1, O2. The intersection point of the O1, O2, and OP, we call M, is the one we should find out very easily. Once we find this M, and we will find the P because this is a midpoint immediately. All right, so that will be easy job. From the two system linear equation, we can find out this M easily. You can see the equation O1, O2, because the slope, look at this one. This slope is in format, it will be 3, 7. The one perpendicular to this one should be in the form 7, -3. In the easy way to write the line perpendicular to this one, we should write a 7, -3 as a coefficient for the one perpendicular to this OP, the common chord. So you can see we write this one as 7, -3. Because it passed through 3, -2 for the points. You can see 3, -2 is the point it passed through. So we just directly write this form 7, -3. This will be the point the line passed through. So we quickly get the equation of the O1, O2. So we get the two equations about X and Y for the M. Once we get these intersection points, that will be for M. And we get the P, because P is just M is the OP intersection point. The coordinate of P exactly twice as much as the coordinates of M. So you see, we just double this one, just cancel the 2 with the denominator. You get a 189/29 and -81/29. So we get this A plus B, 108/29. We get the same answer as the first method, algebraic way to solve it. But these are give the geometric meaning about these 4 lines. So that's also a very nice solution then. So to this point, we're done then.